Okay, a fourth degree polynomial passes through a point and has a bunch of zeros. Determine the equation in factored form using only integral linear factors. Okay. I'm going to do a very rough sketch of this first just to make sure we understand what's going on. This polynomial goes through 1, 2. It has a 0 at -1. It has a 0 at 0. It has a 0 at 1.5. And it has a 0 at 2. It's fourth degree, meaning it's typically either W-shaped or M-shaped. So if this were W-shaped, it could come down and back up, meet that point, down and back up. And yeah, if it were the other way, it couldn't meet up with 1, 2 properly, so it's got to have a positive leading coefficient and be W-shaped. So its equation, I'd rather write y, but they seem to want p of x, is going to be some constant, more about that in a moment, times, at each of these zeros tells us one of the factors. So -1 means we have x plus 1. The 0 means we just have x. You could write x minus 0 if you really wanted to, but I'm not gonna. And then you have x minus 3 over 2. If you just jumped out of your chair in protest, I know, I'll fix it in a moment. And the last one is 2. Now, this is not okay for the question that they asked because they said integer factors. 3 over 2 is not an integer, it's a rational number, and so it's not okay to write this in this way unless I fix it now. The way you fix it is very simple. You just take this factor and multiply it all by 2. Take whatever the denominator is and multiply through by that. So this polynomial, which I just wrote, is equivalent to the following polynomial, where all I'm going to change is that second last factor. X plus 1 is the same. Still have x. But if I multiply all this by 2, I get 2x minus 3. And now everything in there is integers, and now we've done what they wanted. It's now integral linear factors. The one thing I'd point out is if you do this equation and solve it for c, and then you do this equation and solve it for c, you'll find that the c's are different. The fact that this one has been multiplied through by 2 is going to mean it doesn't need as big of a c value to do the same things that this first curve does. So maybe I'll call these c1 and c2 just to emphasize that they won't be the same number. But the way you lay out the polynomial is the same. The way you solve for your c is the same. Just don't expect these to give the same c value. Doubling this thing to turn it into a whole number changes the c that you're going to get. So there it is using integral linear factors. And if we need to know what the c value is, I'm going to use my integer form because it's clearly the one that they want. Our curve has to go through 1, 2, meaning when x is 1, y has to come out to 2. So let's make that happen. Y equals c x plus 1 times x times 2 times x minus 3 times x minus 2. So that's c times 2 times 1. I'm not going to write it. 2 times 1 is 2, minus 3 is -1, and 1 minus 2 is -1 again. The negative ones cancel out. They just make a 1, and that's irrelevant for solving this. So we get 2 equals 2c. Oh, well, that's a little anticlimactic. C is 1. So our polynomial is going to be, I'm going to change the sequence a little bit. Normally, if you have a factor that's just x and it's not a binomial, you put that out front. And then we'll follow that with the x plus 1, the 2x minus 3, and the x minus 2. So there we are in factored form with only integral linear factors. If you want, you could write a 1 out here just so people know that you didn't forget the c value, but because it's a 1, not necessary to write it in.